is, let me tell you why. The reason I'm saying sorry, it feels like progress and chaos, everybody. And the reason it feels like chaos is because there's chaos happening. All right. I expected to write this program in an hour or two, and I've spent 3.5 days, long days doing it. And at some points it works, and then it stopped working. So I'm hoping everything will be good. All right. So let me tell you, and then I was making these slides at the very last minute. So, oh, see, that one isn't supposed to come up already. What is our goal here? Our goal is to learn machine learning. It's to do regression. Regression is when you have a bunch of real numbers come in and the output is one real number. And categorization is when you have categories, right? And we're going to make lots of graphs. So what are your tasks? I only got started on the minimum tasks. I didn't make a suggestions you could do more, but you're going to write some number of functions. Here's a function. It takes in some real numbers and it outputs a real number. So I gave 2 examples. I gave a polynomial of degree 2, and there, look at that's a polynomial of degree 2, and an exponential. Well, I'm calling it degree because it's a parameter that's being set, and that's 2 to the x0 times 2 to the x1, right? So that's exponential. And then the program that I've been working on, and now Chester's on board, is that it plots it. Now, you can't, I don't know if you can see in this plot, the problem, we were working so hard to get it to do a good job of learning that now, Chester, you made it too good. And now they can't see the blue and red line, but there's a blue there line and a red line. And the reason is because it learned them perfectly, right? So you specify a function by what we were just saying, and then you run the program, and it then graphs it. So I don't know if Chester was talking about separating some things, and unless he separated them, all you have to do is define the function and then call all. And what does it do? It makes a big set of data. It computes your function f on all of that data. It does a machine learning thing, and then it plots. This is plotting your function f, and it's plotting the learn thing. So it's doing it all for you, right? So this step, you might admit, is not very hard, right? Then, so here's just a little caveat that Chester and I were having a hard time getting it to learn. And we're actually lying here because this function, so I guess, sorry, just wait, I missed something here. So here, we're plotting, see, it has lots of variables, right? In theory, has lots of variables. So you set, there's a default value for all the other variables, and then it plots the last variable, XR, ranges from 0 to 100, right? And so that all happens automatically, but we weren't having very much success here. This is this guy coming in when it was 2 dimensions. So we brought it down to 1 dimension. So here our function is just 2 to the x0, and then it learns better. So one thing I was suggesting to Chester is we just abandon the hope of people learning necessarily with higher degrees, though we might figure out how to do it. And in the meantime, we can learn functions with 2 degrees, with 1 degree, right? So there's only, right, the function only has this variable, doesn't have the other variables. All right, so here's where I wrote the function polynomial. So, oh, what? Wait, I had other slides. What? Somehow we missed this slide. We started on the wrong slide. All right, so first off, there are lots of parameters to set. All right, so here's a page of parameters. You could talk about how many dimensions there are. Here's x has x1. Oh, actually, that's a lie, isn't it? Sorry, that it should be x0 to xn minus 1, right? Just to be clear. But and you'll see how we at the last minute we turned the number of dimensions down to 1 because it plotted better. It worked better, right? And then each variable is going from 0 to up to 100. Here we're not categorizing. We'll talk about categorizing in a minute. This is the number of training data, the number of test data. We're currently doing the function polynomial, and you're supposed to make up more functions to add in there. Whenever we graph 100 points at the current. Here the polynomial is of degree 2. This is which variable we're graphing with respect. Remember, we're graphing with respect to variable 0. This is Chester gave us a program which automatically sets the values of the other variables. The log function, it's hard to read. So if you set that to true, it takes the exponential function is hard to read. So if you set that to true, it makes it, it takes the log of everything. This is how you can add amount of noise. Right now we're adding 0 noise. You can talk about how many layers you have on your neural net, right? There's the input, the hidden layer is layer 1, the output layer is layer 2. How many hidden nodes are each layer? Which neuron activation you're using. This is which activation thing you do at each thing. This is the one that's regular regression, not regression, what's it called again? Rectifier, right? Or the rectifier is something that lets electricity go forward but not backwards. What, Chester?
Rectilinear unit, yeah.
Yeah, rectilinear unit. How many epochs is how many times you go through the data. This is how much of the data you look at each time step, right? So the whole, and which optimizer you use. And we could add more in there, right? You could add more parameters. And so the goal is to play with these parameters and tell us what you get out of it. So how do you set the parameters? Here's some examples. If you just call set, AP stands for what? Stands for
attempt parameter. Attempt parameter.
Attempt, thank you. I keep remembering what the A is. Thank you. Attempt parameter, right? So if you just call set AP, it sets it to the defaults. And when Chester and I were playing, we kept changing the defaults, but that's not what you're supposed to do. I mean, ideally, you keep your defaults. Well, you can change your defaults if you want, but let us know you've changed them. And well, maybe you shouldn't change them, so we know what the defaults are. Anyway, how do you? This here sets the defaults, and so if you then print AP, you'll see all the values listed here. And if you call AP with like this, then it automatically sets all the defaults. And then on top of the defaults, it changes function to exponential and degree to 3. So here you have, oops, I didn't cut it. I cut it too small. Function changes to exponential and degree changes to 3. You'll have to just trust me that happened, right? And then here I can say, print the number of dimensions, right? The number of dimensions is now 1. I can say print what function it is, right? So you say AP, and then in brackets, you write function, because remember up here it said function, it says function. And as Chester says, if you type that in wrong, it will
Give
not
you an error
tell you.
message. Yeah, it'll tell you now.
It will
It's gonna
not
give you an
tell
error
you.
message.
It will do. I've spent hours debugging things because
I changed it. So if you don't put in one of the things that we have as a default, it'll give you an error message instead.
Oh, it will. Oh, but then that fixes your problem. Isn't that what your problem was?
Yes, that was what my problem was. So I changed it to give an exception instead.
Excellent. Excellent. All right. So maybe that's fixed because I really did have some typos in there and it was causing me grief. All right. And then here you can do it, right? So this says AP function. What's AP function return? It should return, well, we changed it, right? We changed it to exponential. So this tests that it's exponential and it says it prints excellent, right? Everybody follow that? Everybody that's here and has already looked at the
Sir,
code?
I have a question.
Yeah.
You said that we were supposed to play with these parameters, right? But you
Yeah.
also said that we shouldn't change the default ones.
No.
so?
No. Yeah. So to make life easier for Chester, who's going to mark it, I would say we might change these defaults up here, but maybe when you hand in something, let's assume everybody has the same defaults. And then the way you change them is you change them by doing this.
So we don't change it at the very beginning, but we can change it by the line 43. The way
I think, yeah, line 43.
Yeah, line 43.
So when Chester is marking it, if he sees this, he'll know that you changed what you changed, right? You know what I'm saying?
I see. Makes sense.
Right. He will assume that everything is the default unless you've changed it.
Right. So only the things at the bottom I'm going to be looking at as change. Everything else I'm going to assume is the same. Most likely, I'll probably have to copy your code into a different workbook that has the defaults for sure.
Yeah. In fact, one of the things I said is we don't want to give Chester any more than you've changed. Don't give him lots of copies of things that he has to look through. Unless you've changed it, don't give it, right? So this here would just simply say what's been changed, right? Does that make sense? And right, so that was just the same page again. We did this already. Right. All right. So what was that? That was, here, did I tell you this? This is just computing the function, right? So here it's, the function is FF that you give an input X and it, now of course, X is of type, right? X is a tuple of n values, right? And so X comes in as a tuple of n values. And here I'm taking the product of them, right? I start off, I check, is AP, if AP is a function, then I do this, right? And if AP is an exponential, I do that. And in my function, I set y equals 1, and then I keep multiplying by xi squared. I go do x0 squared, x1 squared, x2 squared, x3 squared, right? So that's the type of thing that we're looking for, right? I've seen these, I've given these slides before, but in case anybody missed them, I think it's fun doing them. And especially if we're narrowing it down to one input function, then this is exactly what we're doing, right? Oh, I guess I lost my first page. My first page said we're going to approximate this with some neural net, all right, with one hidden layer. And what is this node going to say? Well, I put a weight of 1 here and a weight of negative W1 here. And what does that do? Well, it has a Z value come in, right? And the Z value is a linear sum of the weights. So it's X times 1, and then 1 times minus W1, right? And then it checks to see, and that evaluates this. And then it puts it here, I got a little threshold, right? So it puts through a threshold and it fires 1 if this Z value is positive, right? So if you rearrange it, it fires when X is bigger than W1, right? So there's W1 and over there it fires, right? So now I'm gonna one thing I could, why did I put this weight as 1? Well, because if I multiply this by D and I multiply this by D, how does it change what happens here, right? It changes nothing, right? Everything gets scaled by D and nothing changes, right? So then we take this and we feed it into the output. And so what does the output get? Well, if X is smaller than W1, then we get this 1 times C0 plus, well, this is giving us a 0, right? So 0 times W, it gives us C0, right? It gives us this value, which then plots like this, right? Does that make sense? And now what happens if X is bigger than W1? Then it gets 1 times C0 plus, this is firing 1 times W. And so we get C0 plus W. And that's this value here, right? But we want this value to match up. It's not a coincidence. I got it matching up with the function. So what value do we want? Well, we want the value C1, whichever is at the function here, right? So I need these to be equal. So I set this to equal this. I rearrange and it tells me what I want my weight to be, right? So we put that weight there and then it gives me C1, right? And then we do that for a similar thing for for this whole network here. And we can ask what value will it be outputting for this value of X, just as an example, right? Note this value of X is bigger than W3 and smaller than W1. We're in here. And what answer do we want? We want the answer C3. And how do we get it? Well, who fires, right? The first neuron fires because it passed W1, and W2 fires and W3 fires, but W4 doesn't fire, right? So what's our sum? Well, it's 1 times this plus 1 times this plus 1 times this plus 1 times this, but plus 0 times this. And you'll see how it all cancels and we get W3, right? Does that make sense? So what I'm claiming is that if you took any neural net with threshold gates, even though you can't learn with the threshold gates, suppose you had some neural net with threshold gates, and you fixed all the variables but one, and you varied that one variable, and it could be some big complicated neural net. I claim that this is what the graph will come out as, right? Because and how many steps are there? It's how many nodes you have at this first layer that X is feeding into, right? So you might want to test this out, right? If we go back to our parameters, here we have where's the number of nodes? Hidden nodes. I don't see hidden nodes. Isn't hidden nodes somewhere? Oh, it's under here. That's where it went. Sorry, let's go back to the there it is. Number of hidden nodes is 212, right? So in our plot, I think it's divided into 212 pieces. So if you divided it into a smaller number of pieces, you can see what would come out, right? So that's the kind of thing people might want to play with. So then what's the next step is you have to specify, we're going to switch over to categorizing, right? So you're going to specify, we're trying to classify the X values, right? Remember, we already have a function where you give the X values and it returns a Y value. So we're going to use the Y value to classify the X's, right? So here's the code that you're supposed to type in yourself. Well, you don't have to do all this. You just type this right here, right? You change, the categorized before was just the empty list because there were no categories, right? And now I changed in my set AP, we got categories being, there are 3 thresholds. So that's going to mean there are 4 categories, right? What are the categories? Is if you're below 10, you're in category 0. And if you're 10 to 19, you're in category 1. And if you're 20 to 29, right, you're in category 2, right? Does that make sense? Hey, Shanaz, how's your husband doing?
Hi. Oh, he's fine. I just had to drop off some stuff in Newmarket and drive back, so I made it. Yay!
Excellent, excellent. Nice to see you.
I'm happy I could join. Yeah, I wanted to see what you do.
Excellent, excellent. Well, we're kind of into it, but this is just saying. Let's have a quick recap.
Oh, you don't have to. That's okay. That's okay.
We're going to define.
Okay, thank you.
The first step is you code up some function.
Yeah.
And we talked about how to code it up. And then you say all, and it automatically plots your function and the learn function. The way you set parameters, we talked up here about how to set parameters. So do you want to do it with lots of different settings of your parameters? And now we're getting into thresholds. So here, as I've said, you specify 10 thresholds, and that automatically takes your Y value and categorizes it. Right? Does that make sense?
Okay.
So what does that give you? Well, I was going to give you the command, but let me tell you what the command is. It's going to have various categories, right? It has a category at 1, right? Any Y that's less than 1 is going to be down here, is going to be category 1, right? And any Y that's less than this is going to, right? Then there's going to be the guys that are in this range will be category 2, right?
Mhm.
And anybody who's above this Y is going to be category 3. So it's probably categories 0, 1, and 2. Oh no, not 0. You don't have to say 0 because it's goes to infinity. I think this just has categories 1 and 2. Right? Does that make sense?
Okay. Yeah.
We'll look for the code when we get it. And so this is actually, we're getting much better results in getting the machine to learn. We struggled. Poor Chester and I were struggling to get this to work. And now you can't even tell there's 2 functions. The red one and the blue one are right on top of each other, so it's doing perfect. But we're cheating by having only 1 input variable. With these others, we're able to, when we're doing classifying, it works really nice with 2. But you can see there's still some error, right? It's getting some of the answers wrong. All right.
Yeah.
All right, then. So what else do? You try different things, right? You repeat what we just did up there, having some functions with these parameters, having some classifiers with those parameters. You try a whole bunch of different parameters, and every time you do you try it, you have some parameter that you're changing, and you have various values that you want them to change. Now, I wouldn't have 100 different values because each time you run it, it takes a few minutes, right?
Yeah.
So you want to get some sense of how long these things take to run. and only having, a few parameters. But what might you change? You might try different functions. You might introduce error to it. And I have a routine already. All you have to do to introduce error is right now I have a value 0 on the parameter error. And you have, if you change it to 1, then it'll add plus or minus a half to your error, right?
Does noise count as error too? Noise.
Oh, no, sorry. Here I'm calling it error, and in the code I call it noise. That's
Okay,
definitely a typo. Let's bring this back to noise. Yeah, thanks for that.
So we can only, sorry, we can only do it 0.5. You're suggesting
No,
that
no,
we
you
should
can do anything you want.
then.
So I don't know whether this is correct or not, but if what I'm adding a random amount of noise between plus a half your noise setting and minus a half your noise setting, so that the range of error is noise. So if you set noise to 8, it'll add a random number between -4 and +4. Is that maybe that's the wrong definition. Maybe I should, because if it was standard deviation, maybe I should remove that divide by 2. So if it's noise 8, then it'd be plus or minus 8. I don't know. It doesn't matter, right? Right? You can change anything about your neural net, right? You can change anything about the learning process, right? And then we will graph what happens, all right? So the horizontal axis is going to be all the various parameter values that you're trying. And the vertical axis will quantify how well it does. All right. So what code do you, I'm going to make you guys write lots and lots of code. All right. You want to see what code you have to write to get the output? Here we're saying if you just run this, then it's called plot AP, right? So it's plotting a graph that's, what's my A again?
Attempt.
Why can I not remember the word attempt?
Maybe renaming the dictionary would be good, or maybe that's a bad idea. Yeah.
Exactly. So we're going to try various attempts. And what are we trying? We're trying, this says which parameter you're going to vary, and we're going to vary the degree. And what values is degree going to take on? It's going to take on 2, 3, 5, 10, right? So here it's plotting x squared. Here it's plotting x cubed, x to the 5th, x to the 10, right? And here's another trial at it. Again, so what it does over here, see, we're changing in our global variable, we're changing the default function to exponential, and we're changing the max from 100 to 5. And then within those settings, we're going to look at degree being 2, 3, 5, or 10, right? And I just made up lowering the max to 5. But the reason I did it is because I was worried that my exponentials might get too big, right? But anyway, it was also an example of things you might want to try, right? So if you type this in, then the result is really pretty good. Look at this. So what does this say? You'll see there's a point here, here, and here, right? Maybe we should change this plot so it's a scattered plot instead of a line plot. But that point says when we have degree 2 and we did the learning, it had effectively no error, right? But when we do degree 3, we started to get some error. And degree 5, we had more error. And degree 10, we had more error, right? So that's kind of what we expect. Now, maybe, Chester, I was thinking about changing it so that when it calls this thing here, maybe we should ask that nobody puts too many things here so it doesn't take too long to run. And maybe it should give us the 2 picture, the 3 picture, and the 5 picture. in the 10 picture, right?
You said last class, 6 or said half a dozen or a dozen, you said.
Oh,
Was that
I'm just making this up. And I
Oh.
said that also, this was before I was actually getting it to run. In order to get it to run, in order to get good pictures, we've upped the parameters. And so the running time is slower. Basically, you try things. I'm saying start small. And if it's working small, then bring it up, then try something else.
Okay,
Right?
yeah. Mhm.
Right? Is that
Right, Adnan, right?
right? And right, so this is a slide I wrote before, right? I coded it up and we kind of saw what pictures we got. And so you're supposed to modify my examples and somehow report what you learned, and don't give your code, but don't give any code that you've changed, but don't give any of my code, right? Because Chester doesn't want to look at it. And then somehow, if you do something really impressive, you'll get a higher mark. And if everybody does the exact same thing, then you all get the same mark, right? I'm not, quite frankly, just to let you know, I'm not that worried about everybody getting the same mark, because in the previous tests, we had really strong deviation in marks. So I'm not worried about separating the students. And so if people have more energy, should we flip through more of the code?
Maybe we should make it such that they can all achieve maximum marks by creating something that's quote unquote, you have to do this task and accomplish this error with I'm trying to figure what settings you need to get that error, that kind of thing.
Yeah, well, we want to give some creative here.
Some flexibility. All right, cool.
All right. I mean, you don't need to study most of my code, so our code, it doesn't matter, right? Here we imported everything that needed to be imported. Here are global variables. So anywhere in the program, these are variables that are aren't going to change. I don't know what custom function is.
What that is a way for you to define a function to replace ff.
Oh, all right.
So if you wanted to, let's say, do 2x plus 1, then you could code that custom function using that.
All
That's
right.
all
Well,
we don't
I
want to
thought people would just add it to the.
Yeah, I don't think they're going to do that. It was just something I added earlier on.
Here's
right. I don't think they're going to do that.
Here's code that don't ask me how this works because I stole it from the internet. It takes the right. It's kind of fun that what machine learning gives you back. Remember, it's the classifier. The probability is the cat. The probability is the dog. And I want to say which object has the highest probability. And these were starting. Chester, you changed the order so it doesn't flow as well as a read, in my opinion, right? Because I would
possibly
first say,
group the math things together.
Or yeah, it's true. But we got
the rest of the orders should be the same.
Okay, here, where's F? Okay, here's F. So this is the code that you're going to have to modify, right? So here it says, if the function is polynomial, then you do this, right? If the function is exponential, do this. So you add a couple more in there, right? You say, if function is the Adnan function, then you do
so
this.
That's what custom function is for. I don't want them modifying. I don't want them modifying this one.
Why?
That's why I added custom function. So if they set a value for custom function, they can just implement whatever they want down at the bottom instead of doing it up here.
Yeah, but you might want a bunch of them. Why can't they just stick it in here?
Yeah, they can do a bunch of them, but do it down at the bottom. Don't do it up in this quote unquote library code. Modify the client code.
All right. All right.
So it'll replace this function with custom function if you set up a function for custom function.
All right.
So sorry, sir. We add more, or we just the last part that Chester said? I'm confused about that. Do we add something here or somewhere else?
So what I'm saying
the
is
functions.
you can copy this code and use that as status code if you want.
Okay.
And paste it down at the bottom and modify it down there. But don't modify up here because I'm not going to come up here for each person.
No, but I told them that it doesn't matter where they do it on their screen because they're just handing you a screenshot of what
The
they changed,
screenshot. Okay.
right? If they don't
Oh, they're not
change
submitting
it,
the code, they're just submitting screenshots.
what do you want? I wouldn't.
No, I don't know. What do you want me to grade? It depends on, I mean, it doesn't matter to me. I was planning to just let them submit the code at the bottom and some JPEGs of their
right.
graphs.
All right. I mean, you have to do it. My thought
Yeah,
was
I
that
prefer they submit the text along their code, along with the screenshots of the parts that they want to highlight, right?
exactly. So what I'm saying is they have more of an essay of, oh, I tried this, and here's a screenshot of this image, and I tried this, and here's the screenshot of this graph.
Exactly.
And oh, and here's a screenshot of I changed this code and I changed this code. They make it more of an essay that'll make it to optimize
for a
how
report.
easy it for you to read.
Right. More of a report than a
It's a report.
right.
What would you hand to your boss? Your boss
Exactly.
doesn't want to see, right?
But I also want to see the code
Well,
because I want to check to see if it's actually producing what you say it's producing, right?
right. Well, I'm saying give you all the code that they changed.
Right. What I'm saying is that I restricted the changes down to the bottom. So if you look on the table of contents on the left, if you scroll down.
Well, I don't want to completely restrict them that, because if somebody wanted to be really creative and they said, hey, I didn't like what Jeff did on this, and they want to, in fact, how do you get an A+ is you really understand it and you make it much better, in which case they should be able to change whatever they want to change.
All right, let's go with that.
But they only give you what they, right? It's a document, and they'll have to tell you what they changed and how they changed it. All right, so this is the function that YY is the output of your FF value, right? And it tells you what category it's in, right? And then F is the function, F of X, well, is your function FF categorized, right? So see, it says, if there are no categories, then just return FF. And if there are categories, then you take the FF and you categorize it, right? So it tells me if my X, how do you categorize your value X? Well, you first say, what is my F value of it? And then in which category is the value Y, right? It returns F of X is a Y value, and then it tells me which category I am. Are you guys following that? Yeah. Then it's hard to scroll. Predict. Definition predict. I don't even remember what predict Y does. Oh, I see. Right. This function is figuring out, it's returning what the learn values are. And this turned out to be a little harder, right? Because if it's categorizing, then it returns, if you have categories, right? We have a bunch of categories, and it returns the probability. For each X, it says what probability does it think it have, it's that value of X. So here it's the 9 is the highest probability, right? So what we return is that it's category 2, Y0, 1, 2. Right? Does that make sense? Anyway, if you have any questions, that's what that does. This graphs, this just graphs it. This makes the title for the graph. This takes the log of everything. If your exponentials are too big, you can graph the log. This build, right? So what is, right? I don't have my test functions down in here. I like to explain things with text functions. Some of them I copied out, but I didn't have time to copy them all over. it gives you a large set of X values. So what right? It's a big list of these things. And so it starts by NP is this data structure that makes arrays faster, and it sets it all up with zeros, and then it just goes through, and for each X value, right, it gives you a random number. And then once it has all the X values, it then gives you a Y value. Right? Does that make sense? So this is adding noise. And then the learning, right? So you might want to, if you want to play with some of these numbers, right? Chester was playing with them a lot. You change with how many data points you have, you change with how many dimensions you have, you change how often epochs, how many times you go through the data. If you have smaller batch sizes, then it runs faster. You can try different optimizers, different and different activation functions, right? So in fact, here, let's go. A question that I had is here I'm having an activation of a threshold, right? But I think if you had a sigmoid, then these edges would get curved, rounded off. And so you could try that and see if you get rounded off edges. And here I said, well, if you had a rectifier, I don't know what the rectifier would do to it, but now I do know because we plotted some and they look just like that, right? So, okay, going back to the code here, that's the learning, right? And then this is just automatically applies them all. So all you have to do is call all.
So so the actual part that makes the graph is that one, right?
Well,
all.
What this one does is you give it things that you want to change, and then it builds the data. It adds noise if you have noise. It learns, and then it graphs.
Okay, so do you mind, or if you can run it so we can see like exactly how? I'm confused about like kind of the order that we do things.
All right, right. Well, all right. So let's all right. Where all these things are, see, they're all just not used to where things are. And this.
So it's easier to navigate if you use the table of contents on the left, and then you go to the bottom.
Here we go. Here, all. All right. So if you call all, right, what does it do? Is it uses you haven't changed anything, so it uses all the default values, which is a polynomial, and it still, see, we still have some things typed out that were our error checking. We probably should remove those. And then it right creates random. What does all do for you? It creates the random X values. It computes the correct Y values. It gives it to the learning program. The learning program gives you the resulting problem, the learned F, and then it plots. Then we plot it, right? So it does all that for you. And here it's blue and red on top of each other, right? So that's that one. If I used to have an exponential one, but it seems to be gone. You can change various things, right? You could change function to be exponential. You could change anything any of the parameters. You can just, all you have to do is write a change. So here the change we're making is we're changing the AP value categorized from being the empty list to being this list. And you'll see it has 2 breaks. It has a break at 200 squared, which is, 20 squared, which is 400. And it has a break at 60 squared. So if you then come down and see the picture, right? Is this the same running of it? Because it doesn't seem like the thresholds are at the right, that this doesn't look right to me.
The y-axis looks weird.
The
But I'm
y-axis
guessing that's
looks
probably
weird.
log. So if you take a log of 400, you don't get 4, you don't get 1. So I still don't know what happens to 1.
I don't know why. Maybe we should try running it again and see why we got that. But you'll see 20 squared should be 400. So there's a category before 20 squared, and there's a category before 60 squared. And
that's the y
so,
values. That's what it is.
what?
That's the y values. So the first one is 0, the next one is 1, and 2, like that. So
Yeah.
those are the classes. The y-axis
classes.
is the classes, not the.
Yeah. Oh, yeah, that's it. That's it. This is class 0. This is class 1. This is class 2, right? And where are those classes broken? There's one broken at 20. Why is it a break at 20? Is because the threshold was 20 squared, right? If you give me the input 20, what does it do to 20? It's function f gives you a y of 20 squared. And once you have 20 squared, that puts you on the boundary of whether you're in this class or that class. Right? Does that make sense? And then this guy we've seen already, what all you do is you call this routine with what you over here you say everything that you want to change and have fixed, and this says I want to change degree with various options, and it gives you this graph, right? So you were asking what do you need to do, right? So let's review what you need to do, right? You come over here, Chester put in a table of contents. So you go to FF and you have to add, somewhere you have to change FF. You could do it here. I would have just done it here, but Chester might want you to do it at the bottom, but given you're giving him a screenshot, it doesn't matter, right? You change that. And then literally you just write things like we're doing. Then you type this, something like this, right? And have it run. So let's see if anything's been changed and see how it runs. How do you run? Oh, and then you come up here and you save what you're doing. And how do you save it? You save it as save as drive, right? Because I can do save, but you cannot do save. You have to do save, copy to drive. Of course, once you have it in your drive, then you hit save, right? And then you come up here to run, and you run it. And you'll see it just ran, it's running the boxes one at a time. And I'm not running down here to see what's happening because I know it's slow, right? Here it's doing all, right? It's doing, as it runs, here's how much time's taking each step. Here you can see our loss function is getting smaller and smaller. Chester was being really smart. We were looking at how much the loss function changed every step. And so you can estimate how many of these epochs. Epoch is every time it goes through the data, right? And we were having it changing only 1% or 0.1% every time. And so if it changes 0.1% every epoch, then that tells you you're going to need to have about 1,000 epochs, right?
So the loss function is the function with giving us the error. Sorry, I forgot what the loss function was.
What does MAE stand for again?
So the loss function is mean squared error. So it takes
Yeah.
the square difference between each of the values and the correct value.
Yeah.
And then it sums up those errors.
Yeah.
And the MAE is the average across all the data points.
The average difference
The average difference. Yeah.
without squaring it.
Squaring it. Yeah. So you take the difference between the point and the correct answer, and you square the prediction against the correct answer, and you get the difference, right? You take the difference and you square that. Once you square that, you take an average of all those differences,
How's that
of all the
different
square
from this?
differences. No, that one is the sum. The one on the
Yeah.
right is the average.
You know, I was wondering whether it was some, but I tested
The one
it
on the loss is the sum.
by giving more data, and it didn't change.
It should,
All right.
unless it gets it more right? Because that's at the end of the first epoch. So it could have gotten back down to the same correct number of them correct.
Right. Anyway, this is what they're doing. I was wondering whether we should take square roots of it or something to get back to, but anyway, those are our parameters, and you see when they get small, it's better. Right. And then we don't have as many. Oh, we could put more examples in here. Well, here's the categorizing one, right? We called this, and it did these categories, right? And you can see where it did it. It's here, it got better and better, right? So it's 98% correct. And you look at the picture and you can say, yeah, about 2% is wrong, right? So let's try, let's come up default parameters here, dimensions, right? Dimensions is the one we are having problems with, right? So you come back down to something like this, and you put in here, you put a square thing for everything you want to change. And I want to change the dimensions, comma, 2. I want to change the dimensions to 2. So now what? Now every value is going to have x1, x0, and x1, right? And we could change here. Function. By the way, it's 2 brackets, 2 quotes, and 1 quote are the same. So we might not be consistent. Right? So here I'm changing 2 dimensions, and what that means is it won't do as well, right? And we're changing the function to exponential, and then we can come up here and we can run it again.
It should take more time too, right? Or is you changing dimensions?
Yeah, but we're not changing the number of data points, so it seems to be happening about the same speed. Well, that's another thing you could report on. You could report on plotting not just how well it does, but you could also plot the running time, right? So here's our exponential function, and I don't know where the blue one is. It didn't do it at all.
Yep, it has not a number as all the outputs, so I suspect something went wrong in the model.
Oh yeah, so something went wrong, right? I don't know why something went wrong. And then down here, it we didn't change this, right? We didn't change that. So should we try something else? It doesn't, right? I do find when you're doing categorizing, it doesn't mind dimension 2, but when you're doing fitting a function, it really doesn't like dimension 2, right? Maybe if we get rid of, let's get rid of this, because it really isn't good at it. And And why don't we
might
put
want-
in, oh,
Log scale, yeah.
yeah, let's put in log. Do you remember what was it just log?
I have
Scale.
no idea. I always go up to the defaults and copy it.
Let's try log scale and see if it does anything. We put true. Right? And then we run it. Oh, it's giving us our NA again. Something's gone wrong.
Yeah. Maybe the calculation of the exponential is not happening properly.
Maybe they got too big.
Actually, there's no error checking for if you put the right thing in the EXP part. So maybe you put something there that's not what it's expecting. Because that doesn't have error checking yet.
Um,
So if you go to FF and you'll see what it's expecting as the value for thing, or maybe it should be there in the comment. Yeah, it says EXP in the comment, but just check the FF and see what it says. Scroll up in the scroll up. Yep. All right. Then scroll down a bit. Let me just see. Poly and
EXP. What did I
that's
have?
correct. That's what you have, I believe.
All right, well, that's the truth is
Dimensions
sometimes
and-
it works and sometimes it doesn't. So if everybody gets horribly frustrated, we will work on making it good.
Sir, it's not really about getting how accurate your how low your error is, right? It's about trying different things and reporting it.
The goal, yeah. So
That's the goal of this.
here, I tell you what the goal is. There's really a very clear goal. And the goal is for you personally to find it interesting and to learn stuff. Right? And you personally, like Shanaz, when you're at Christmas dinner with your parents, if your parents
Sorry,
are still,
what was that again? Sorry.
I'm talking about Christmas dinner with your parents.
Okay, yeah.
What is my goal of this assignment? Is that you will be able to say, oh yeah, I did some machine learning and we learned some digits and I wrote some old things and it gave me neat graphs. And it was great. I loved it. That's our goal.
Mhm.
Our goal is for you to say that at your Christmas dinner.
Okay.
All right. How are you feeling about it? Does it feel like it's manageable?
Yeah, so if it just does that NA thing, it doesn't run the way it's supposed to, then what do we do? That's it? We just leave it at that?
That being said, is we complain to
Chester?
Chester and me and
Yep.
see if we can get it to
Okay.
run,
Yep.
Okay.
right?
Definitely. The best thing is to complain. That way we can
So-
try to look into it.
Right.
So
Well-
do we talk to Chester directly or do we go through you?
Forum
Does
is probably
Chester
the
have
best
an
place,
email?
so everybody can see the same problem.
So here, if
Yeah.
On
Chester,
eClass.
let's go to there and then hit this dot. And then, I have a hard time when there's an extra screen because my mouse on the white, I don't see the mouse. And then when it goes off the screen, I lose it. So he added, usually I have another thing over there. What happened to my at the side?
You're in 1090. That's why you don't see it, I think.
Oh, that's it. You got to go to the right course, guys. Silly guy. Oh, still, it's not letting me. It's not seeing over.
There's a Q&A section.
There's what?
It's right there on your screen at the bottom. Q&A.
Oh, Q&A. All right. I just can't see my mouse in this white screen. There it is. There it is. There it comes down. Is this what they're supposed to fill out?
Yep. So they just put questions on there and I can get back to them.
Can we also get your email so in case something private you want?
Yes, I was gonna say the same. Email, please.
Well, email would be harder to answer for everybody, but sure. It's cyk@yorq.ca. I think it's on eClass as well, on the participants.
Yeah,
Pretty sure
we
it's
don't
there.
want Chester to spend much more time. It's
Answering
usually
the same questions.
than he's paid for. Somehow it used to have a thing on the side here. I don't know what happened to it.
Oh, I think E-class got updated.
Did it
Because
get
when I
updated?
turned
Is
it
that what
off this morning, it updated it. So maybe
Oh.
they changed something. I don't know.
Yeah, because usually you get a list over here of oh, here's course announcements over there, a forum, and because like if you so there it is going into forum for testing, forum for Q&A. This is the one you were talking about, right? So
Yep,
so
that's it.
add a new question. There, I guess we could do it. How is everybody doing? Are we doing okay? And I don't know what I'm going to do in classes, the next couple classes, right? So I guess what we'll do is people will say how they're doing, and if people have nothing to say, I will talk about machine learning, and we can be very casual. Everybody can bring some pizza.
I certainly feel better than before attending this session.
Good, good. I don't think we're asking too much from you, right? You just call these routines.
And
And if
people
they
that
don't work, we'll figure it out, right? And if when does it officially due, right? It's due Friday? When does it due? Friday?
It's due, yeah, Friday. So
A
if
week
it's
today.
like today is Friday, so next Friday.
Yeah, yeah. And if, if everybody, if it's really not working, right? Because we do things and everything doesn't work, then we'll do something. We could change the due date. We could try to fix it. We could, right? And if you really want, I'll give you another test on Turing machines.
Mm-mm. No.
I love the DFAs and interface. If it turned out to be that, DFAs are better, I think.
If sorry, what?
DFA and NFA, right?
Oh, you want that? All right.
I don't want it, but if for some reason that
No,
I hope it never happens, but
Yeah. I only say that to threaten people who have the I don't want to be doing machine learning look. It's my tease. All right. Any thoughts, or should we go? Should we stop?
So that's it, right? So we just go and practice and that's it. We enter our own stuff, data, and that's it.
Yeah, I would start by actually, Chester, do you know the advantage? I'm going to agree with Chester now. If somehow you can get all your stuff down at the bottom, advantage of that is when we give you updates, you'll want to merge what you've done with our updates. So to the extent that you can keep the two separate would make it better, right? Because if you do all this work changing our stuff, and then we come and say, hey, we're changing that because it's not quite working, then you'll be more frustrated, right? So if you could try to keep track of what you've done, because the chances are we will be giving you updates.
Yeah, I fully intend to make some fixes based on what we
Right.
just saw today.
Right?
so by doing it at the end, we mean that we create separate boxes, right?
What you can do is let me show you. Let me share my screen. Let me just show
Or
you what
you
I
share
would
your
want you to
screen
do.
and you show us how to do it.
Yeah, let me do that.
Yeah,
I don't
that'd
really
be
know what
nice.
you mean.
Yeah.
Do I have to unscreen share?
I'll stop you when I do mine.
All right, you did it. You did it. I didn't have to do anything.
Well, yeah. But anyway, so if you look at the bottom, I basically tried to separate everything into two sections. A section where things shouldn't need to change, which is all this stuff at the top, and this stuff that shouldn't need to change. And it's, well, I had planned to put some examples in here, but that didn't work out. And then this is where you can override the implementation, our implementation for the part that determines what happens. How do you take an X and map it to a Y? So for example, if you want to say that you want to just multiply each X by the other one. So you take X1, X0, multiply by X1, then you multiply the product by X2, multiply the product by X3, and just multiply all of them together. And that's how you get your Y. Then this function does that. So you just uncomment this, and to uncomment it, you press Control and /, or you could just delete all the little things at the front. Both of them work. And then that will just replace the function. So our function now doesn't do anything. It only just calls this function and returns
Maybe
that
we
value.
should have a number of them. They might want.
Yeah, what I'm saying is you can do whatever you want in here. You could have a number of if statements. You could have whatever you want. You can do. So if you look at ours, there's a if statement that says if the function is set to poly, you do this. If it's set to XP, you do this.
Right.
So you can do in your function down here whatever you want. So you could let's literally say, let's start off with exactly what Jeff has up here. Right. And then you just change it to that.
Yeah, but Chester, then
Yeah.
why don't you go back to our FF function?
All right.
Let's change right now, change this function so that it says if AP function is student1, right? Then call something, right? And if it's student2, call something, right? Because they have to,
Well,
this
what
ultimately, or they
right.
change all of FF.
So the way it's working right now is I don't need to change that for them to be able to do that. So I do need to add one more thing, an error message, if it doesn't pick one of these.
Are they going to rewrite my poly thing? They might not want to call it.
They don't have
poly.
to rewrite. They don't have to rewrite anything. So let me just show you how it works. So
All right.
let me just give an exception if it's not a recognized value.
All right.
All right, great. So that's that. So let's say they wanted to do student1. That was your example, right? So what they do is they go down here and they say if it's equal to student1. You definitely don't want to keep that part in there. That will be a problem. Because if you keep that part in there, it's going to call itself, and then you get a recursive function that will not terminate because there's no base case. So if student1, then you want to do his polynomial thing.
Right.
So let's just take out, let's leave the rest, it doesn't matter. And then here we say, and then let's say we want to make it different so we can know it's not the same thing. Shift everything to the right, I guess.
Shift it up, but that's good enough.
What's that?
Yeah. I was just,
I spelled this wrong, eh?
I was making a math nerd statement. If custom, oh, I see. You have stuff. Is this my FF
No, this
now?
is FF. This is FF. I added an error, so I just have to fix the error I added.
It's not none. Oh,
Okay, so student and it's running. Let's see if it works. It's actually doing something. It's running down the error. So you can adjust the values of number of training points and number of epochs to improve your running. So if you notice like your error is not going down enough. So right now the error is going down pretty good. So it's right down to about 28, and that's really actually fine. But let's say it had stayed somewhere like 700, then you get something that probably doesn't fit very well. Then you might need to add more epochs or more training points. And there's an error. Of course, there's an error. What did I do wrong? Math domain error.
why don't we just take FF and move it down to their world.
Yeah,
and
I
then
just tried to modify FF. I guess my plus something was the problem. I don't know what I did wrong.
What's math domain error? What's that?
No idea. So
Oh,
Stack Overflow
okay,
probably knows it.
okay,
That's
okay,
Sounds like
sorry.
it divided by 0 or it took the square root.
Yeah, we first tried to take the log of 0. That
It's
was
good that you can search Stack Overflow right there. You can just a click. That's funny.
So let's turn off the log scale.
Yeah, that's probably, it probably took the log of a negative number.
Right. So that's most likely what it is because I shifted it down by 10. Is that what I did?
No, you
I shifted
added
it up.
10.
None of my things should have been negative.
I still don't know how FF is linked to custom. I think if
Oh, you
this-
don't understand how it's linked. I can explain that. That's easy. So FF
Yeah,
by default, if you look up here in global variables, custom is not defined, right?
right.
So if you don't define it, then
Right.
custom stays undefined,
Right,
right? Custom is still none. So this doesn't do anything. This part gets ignored and your function takes precedence.
right,
But if you define it down here,
right.
then ours doesn't do anything anymore. All ours does is call this one.
Oh, so
Once
then,
you
it's,
uncomment
then
this-
it's not doing AP at all.
AP. Yes, it uses AP. Well, you use whatever you
Not
want
if
in this
it's in
function. You can
here.
implement it
do
however you
your own
want.
AP down there.
You do whatever you want. You can copy what we have and use that as a basis. You can do whatever you want. It's completely, you can use any function. It's not just regular Python code. So this is going to be hard to tell if it's moved across by 10, but I don't know. It could be. Scale is too scale is all wonky. I can't tell.
Yeah,
I
10
moved by more.
was too mild.
It was certainly
Yeah.
some difference.
Is there a
was.
difference? Can you tell it
You
shifted?
can tell the difference. Well, your eyes are just better than mine. That's all it is. I can't tell. There's no way for me to tell that. It
Different
10
than
is
the
just
previous
not a
one.
big number on the scale of things. So that shifts the y by 10. So that moves y up. No, that's not going to help. I moved
Yeah,
y
it
up.
shifts, it shifts up. That's right. I mean, it's when you said it shifts
Up.
over, I said, no, it's not. It's shifting it up.
Yeah,
gonna
well, I thought I was shifting it over. I didn't,
Well,
I
you're
didn't do what I
definitely not
wanted to do.
shifting it over. You're shifting it up.
Since I need to shift it up, I need to move a bigger number. Wait, there was an error. Oh man, I didn't see what the error was. Oh well.
Yeah, lots of errors. This whole process
errors
took
are part
way
of life.
too longer than I expected it to. I'm so glad I'm not a coder. You know, nobody
Oh,
should
I know
go
the
into
problem.
computer science.
I know what the problem is. So right now there's a bug where if you give it classes that overlap, so for example, if you give it,
No,
yeah, if you give it overlapping classes right now, I think that's what causes the problem, but
they don't
I
overlap.
have no proof. Well, these might be overlapping because I just shifted everything by
Yeah, but
200,000.
that
Yeah,
has
these
nothing to
overlap.
do with
Both
it.
of these are 0.
That has nothing to do with it.
These are
Those are
this is going
just-
to give an error. It does give an error, yeah. So it's going to give an error saying that it's flattened, right? Yeah. So that's the problem with that. That I'll try to fix at some point. But let's go up, scroll up. There we go. Okay, so it did move up. So this is definitely, my function is definitely the one that's being used. So student 1 is being used. So once you define custom function, it automatically overrides FF. Does that make sense?
Yeah, sure. Sure.
Okay, great.
I'm
So
good
you can
with
do whatever
that.
you want in here. You can do exponential, you can do whatever, you can copy our
And you
code
can
and
have
use
as
the
many of
standard
them
code.
as you want. Good.
Yeah, you can do whatever you want. You can define other things to put in here because it's just a string, right? So you just say
Right.
is equal to student 2, or you can give them better names. You can use whatever you want. It's
I think you should call it Shanaz function.
sure.
Yeah,
I'm
sure.
not gonna spell her name badly, so I'm gonna just not try. Well, then again, it's on Zoom. I could see her name.
Yeah, I don't mind my function. Yeah, for sure.
There we go. So because these numbers are so big, the optimizer is not bringing the error down fast enough. It's not taking big enough steps to get to the to fit it well. So you can see that the ground truth is curvy, but the learn function is pretty much just a straight line.
Yeah.
It's basically at the point where it's just moving the straight line to be close to this line before it starts to bend it.
Back to what you suggested, right? You said epoch. We should just change the value of epoch to
Exactly.
bring it faster. To bring it down faster. That's what.
So Yeah, so we're going down about half. So I guess another 5 or maybe 10. Unfortunately, I'm stumping all over the student copy. I really should have probably saved a new copy before I started showing you guys stuff. But yeah, I stumped all over it. It's all right, I'll fix it back.
Well, I think you should have some example in your whatever you call it code.
Right, so I'll leave this
That
as is.
should
I'm
be,
not going to take this out. I'm going to
Yeah.
leave this as is. I'll probably actually add back this stuff from FF.
well, they should have an example of how they're doing it.
They have FF, but I'll still leave this all
But
inside of here.
Yeah, but it's not just FF. It's I had to see how to change custom.
Yeah, so custom, I'm going to leave this one student one that we added with the 2002,
Right.
whatever
right,
big number
exactly.
it is. I'm going to leave this,
Yeah.
and I'm going to leave the whole of FF
All right.
in here,
Okay.
so that you have both.
Both.
Plus this other weird thing that I had from earlier, which just multiplied all the x's together. Really hard to learn, by the way, so I'm not sure that's a good function, but it was just an example.
It's a good function. What's wrong with that function?
It was really hard to learn. I had a really hard time getting the model to do well.
That's interesting. Why don't you add it in that, people can learn it?
They can try, yeah. And we're still doing really badly, so this came down and started decreasing how fast it's going down. So it decreased the step sizes and basically did really bad. So even though we took more steps, it didn't do much better. I think this is partly because this is so far away from 0. So it's requiring the model to have really big weights, and the model probably has a regularizer on it that tries to keep the weight small. So it's balanced enough and saying, I don't want to go right up there.
Oh, I see.
So in a real machine learning problem, what you would do is you would
Normalize
standardize your, yeah, exactly, normalize it. And then you have to quote unquote keep those same values as part of your model.
Good thinking. We need to normalize things.
Well, yes, but that's harder because it's not fitting in for our code that we have right now.
Well, I can write a normalizing program.
Yeah, so if Jeff wants to do that, then definitely it can be done.
In fact,
But it's not hard.
In fact, I got it written right here on these PowerPoint slides.
Sure. So, but the thing is, you have to make sure you save the mean and the standard deviation to bring them back. So each time you get new points, you know what to do to them, right?
Right.
So you have to keep that as quote unquote part of your model. So it makes it a little bit more complicated than what we did in the labs.
All right.
Not that much more complicated.
I think that's brilliant. That's maybe why we're having problems. Is because we need to.
Yeah, because as we moved away from the origin, it
got worse.
Definitely got worse. Definitely got worse. And all we did is move away from the origin. We didn't change anything else.
All right.
So for example, if I moved it down, it should do better. Let's move it down. How much was it before, guys? 10,000? 100 times 100 is 10,000.
Well, you should subtract something. Subtract.
Yeah, I think 100 times 100 is 10,000, right? So do 50,000. There we go. 5, is that correct? No, I need a 5 times that. 5 times 10 to the 5.
Why don't you just say 100 squared divided by 2?
There we go. That's better. All right. Let's try that.
I think that's our problem. We should have regularized.
Normalize the stuff, right?
Normalized.
Yeah. It's doing better. So it's taking significant jumps. Oh, I still left on 15, eh? It's gonna run for a little while. Oh, we didn't move it left, did we?
No.
It's going from 0 to 100.
Yeah, it's okay.
Yeah, it's all right.
All right, I'm gonna do that. I'm hoping that will solve our problems, regularizing things.
Well, it should make it less bad for sure. Hopefully. It's not getting any better. It's getting
All right,
down to about
let's
31.
stop. I will normalize things. I will normalize things. And we
Okay,
will talk about,
I'm really curious to see what happens though, so I'm gonna just let it run.
and maybe it'll solve the problem.
Oh, so the error is becoming really tiny now. So this they'll
Well,
keep on
it's
going
31,
forever.
It's not really getting any better. But it's gonna go until 15.
Oh,
And that's a pretty good fit.
Oh, there you go.
oh, you got
There
it.
you
Pretty
go.
good fit.
Very nice.
Yeah.
That's cool.
I think normalizing is their problem. I'm gonna normalize it. Okay,
All right.
guys. I'm gonna go. And
So I'm gonna save a copy for the students that's without this. We're just gonna comment this out and leave this here.
why?
Well, so because they've seen it now and they probably would want to be able to have that as starter code for them to play with, right? I think that might be helpful to just leave that there. So I'm gonna just comment it out and leave it for them.
Right. Yeah, yeah.
And I'm gonna comment this out so that this won't be on by default, so you can use it with Jeff's implementation first.
Yeah, but it doesn't do any harm to have it there.
Well, if it's on and it's not commented out, I'm going to leave it. But if I don't comment it out, then it overrides yours, and yours doesn't have precedence anymore. So everybody starts off with this as the thing. That makes sense?
Yeah, it just uses these polys instead of those polys.
Exactly. So you just uncomment this, and you can
Hey,
start off with this as your starter code.
Actually, no. Let me tell you, I don't like your code, right?
All right. Why is that?
Because if
Mhm.
they add anything, then my functions will no longer work.
Right. Oh, I'm sorry. That's a bad thing. Okay. What's
That's a bad thing. Right?
That's a bad thing.
Because suppose their first example is just to modify something, but to use my polynomial thing. And then they
Okay.
add something they add a new function at the bottom, and suddenly their polynomial example doesn't work anymore, and they're upset. You know, I really think you should just grab this whole
You're right.
FF and move
So-
it down.
I've changed it so that your FF, it takes precedence.
All right.
They don't do exponential or poly, then
right,
they can define it in here.
Good. That's better. That's better.
So long as it's better, I'm happy that you're happy. Everybody's happy? Anybody have any problems, any questions?
Everything's
Chester, you know,
fair.
all I have to do to make Chester happy is be happy myself.
Yeah, I'm pretty simple to make happy. I'm not a complicated person. Anybody else have any questions, concerns, emotional outbursts?
No, not right now, but be ready for some emails. We'll shoot you.
Excellent.
Well,
Excellent.
I think the forum is better because that way everybody gets to see the questions and everybody gets to
Yeah,
benefit from the answers.
let's not try to bombard Chester with unique things.
Okay, sure.
That way other students can have the answer, you know.
As a professor who's been doing this a long time, if somebody asks me a question, the first time I get asked a question, I'm usually friendly. And then if 10 people ask me the same question, it's hard to be friendly.
No, we'll post it in
Right.
the forum. Yeah, that's
So if
fine.
you post in the forum, then that way I only have to answer it once. Everybody gets access to the answer.
So
Yeah.
just in
And
case we
worst case
said,
somebody does answer it again, then I can refer to the original answer. I don't have to say, oh, but I told this other person. You know, that doesn't help them. You know?
Yeah.
It just makes it easier for everybody. So they also see what problems people are having, that kind of thing, you know. I think it's good for everybody to share questions on the forum. I mean, it's not my favorite forum. There is that 15-minute delay before your question does go out.
Oh, yeah,
I'm sorry
that's-
about it.
Just let you know, when you send something on the forum, it doesn't mail it for 15 minutes. It's so dumb.
Right. You have 15 minutes so you can edit it. That's great if you make a mistake, but annoying the rest of the time. And you know, the rest of the time is usually the time.
I think 30 seconds is good, but
Yeah, 15 minutes is
30
definitely slow.
seconds, I've left.
There we go. That was an error.
What
All
was
right.
that?
I had a double quote, which is the escape character in.
Oh,
Some other
okay. It's
language.
really
I don't know what
tiny,
language.
that's why. And I'm blind.
Yeah, there's
so-
another language where that is the escape character, but not in not in.
Oh, this font's too small for you,
Python.
Shanaz?
Oh, yeah, this one
I can
actually
make it bigger.
is.
If you had told me that earlier, I would have made it
Oh.
bigger. But you didn't tell me.
No,
let me make
I'm
it bigger.
challenging myself.
Right.
No, there's no need to do
Are my
that.
I like-
slides
I like-
you okay?
Now I see a beautiful picture. Now the code has disappeared.
Yeah, I'm gonna make it bigger. So I'm just gonna make the
Oh.
screen a little bit smaller. And what that does is that when I share that window alone, it actually gets bigger on your side.
Okay.
Just trying to get the thing to cooperate with me. There we go. That little thing to click on to drag the size, resize it. It's harder to click on than I imagined. There we go. Now let me share that, and then it should be nice and big.
It's the end of the class though. Oh yeah.
That's
Yeah.
bigger, right?
Oh my God.
All right, guys, I'm
Gigantic now.
leaving. You can do what you will.
Okay,
Okay,
thank you.
okay, sir. Thank you, sir.
Bye
Thank you
from
so
here.
much for the session right now. Okay.
All right.
So before I leave, anybody have any questions? Any emotional outbursts?
Oh, thank you so much, Chester. You really are friendly and helpful.
Yeah, thank you, Chester.
Chester's great.
And
Chester's great.
yeah, we
Like
like you now.
try, but I don't know if I will go as far as say friendly. But if you say I'm friendly, I'm gonna agree with you. You must be right.
Chester.
Yeah.
Save this, and then don't change anything until you get email from me.
I'm gonna don't change. I have a whole bunch of changes I want to make. I wrote down a list of things as we were going through this.
All right. Who's gonna go first?
Well, how about after this we discuss what I have, and maybe you have the same things, and then we both don't need to do them.
Well, all I want to do is normalize.
Okay, so I can wait for you to finish that.
Yeah. So I'm gonna normalize now and then send you email. And I don't think it'll take me more than 20 minutes to normalize.
I think you might be wrong, so we'll see how long that takes then.
All right. All right.
But don't work on this copy so that they have a stable copy that they can work with. So make
All
a
right,
copy of
I'll-
this, and then we'll just copy the changes back into this. Is
All
that
right.
Okay.
I'll make a copy.
Yeah. Okay. I just want them to have something stable that they can work with in the meanwhile.
All right.
All right.
In
great.
fact, yeah. Okay. Right. It's still, we don't want two things that we have to merge together,
Oh, I see.
right? If you and I
Um,
both change it.
No.
we will
What
have
we
to
do is
merge
we
our
just delete this
changes.
one, right? At the end.
What?
So we just delete this one and replace it. So
Yeah.
you make a copy and we delete this one and replace it because they have access to the folder, so they can just get the new version.
Yeah.
Yeah. So you make a new one and go ahead, and I'm gonna just wait for you.
All right. All right. Talk to you later.
All right, guys. Bye.
Bye.
Okay, thank you. Bye-bye.
Bye.
Thanks, Jeff. Bye.